This question says, the rate of diffusion of an unknown monatomic gas through a nitrogen buffer gas is found to be 4.47 times slower than the rate of hydrogen through the nitrogen buffer gas. What is the identity of the unknown gas? And I also made a note here of something that didn't make it into the problem statement, that both gases are at room temperature. So the first thing that I'm going to do is set up the equation that we can use. So this is going to be based on the kinetic molecular theory of gases. We know that both gases are at room temperature, which is really key here. So because the kinetic molecular theory of gases states that the kinetic energy is proportional to the temperature, if you have two gases at the same temperature, you know that their kinetic energies are equivalent. So I'll note that I'm going to call our unknown component X for now, and that the kinetic energy of our hydrogen is going to equal the kinetic energy of our unknown component. And to expand that equation, that's going to be that 1/2 times the molar mass of hydrogen times the velocity of hydrogen squared equals 1/2 times the molar mass of our unknown component times the velocity of our unknown component squared. And that's the general formula that we're going to use. I do want to note that both gases are traveling through a buffer gas, but they are traveling through the same buffer gas through the same medium, so this is not going to impact our problem, and we can still use this equation. So now that we have set up the equation, I'm going to start simplifying using the information given in the problem statement. So we know that if X travels 4.47 times slower than hydrogen, where X is our unknown, hydrogen travels 4.47 times faster than our unknown. So therefore we can say that the velocity, and sorry about that, this should be a U here just to be consistent. We know that the velocity of our hydrogen is going to be equivalent to 4.47 times the velocity of our unknown, which is really key in this problem to recognize that. So now I'm just going to plug in this new information to our equation. So we know that the velocity of hydrogen is going to be 4.47 times the velocity of our unknown. And now that we have that, I'm going to simplify further to get that 4.47 times the velocity of our unknown divided by the velocity of our unknown all squared equals the molar mass of our unknown over the molar mass of our hydrogen. And so this is really similar to an equation that you may have memorized, that rate 1 over rate 2 equals the square root of the molar mass of 2 over the molar mass of 1, which you can use when you're looking at two different gases at the same temperature. And that's definitely valid to use in this situation. It's the same thing that I'm deriving with this equation. But sometimes during the test you don't remember these smaller equations, and it's easier to derive this from the main equation. So that's what I'm showing here. So now that we have this, our velocity of our unknown cancels, and 4.47 squared is going to be about 19.98. I'm going to multiply over the molar mass of hydrogen, which is 2 grams per mole, because in this case it is diatomic. And this will give me my molar mass of my unknown, which I end up getting is equal to 39.96 grams per mole. And a lot of the time this will be given in a multiple choice format. So you'll be given 4 different atoms, and what you do is you just look in the periodic table, you say, does this one have this molar mass? And if it doesn't, you move on to the next one until you find a component that does match this molar mass that you found here. So this is how you find the identity. And in our case, you can confirm this by looking at the periodic table, but the unknown is argon.